Hello there, it's Jay here from Jay's Vintage Junk, and today, not particularly vintage this, but I thought we'd have a little look at this. What I've got here is a little mono amplifier based on a TDA2030A amplifier IC. And it's a full little kit I picked up. It's from an eBay seller in China, and basically the entire kit was cheaper than you can buy a TDA 2030A IC for. They usually sell for about £1.50 then, and that entire kit was £1.11p delivered from China. So I thought I'd build it up and see how well it works, and get everything out of the box. I mean, my idea is these might make nice little good substitute amplifiers for old record players and stuff when if it's a solid state unit or it's in a unit that's not really worth spending a lot of money on. Perhaps a little amplifier like this could be the way to go. I think you'd need some form of preamplification to drive most modern cartridges, but even so, it's not bad, this. Well, we seem to have most of the components we'll need here. And we will need a heatsink for it. It doesn't come with a heatsink, and if we're going to drive that thing, we are definitely going to need a heatsink. So that's one thing to keep in mind. But I mean, I've got loads and loads of things with scrap heatsinks on, so that's not going to be a problem really. I'll just tilt you down. I'm going to try and keep this in shot the best I can, but the thing is, if I zoom out too much, then you can't really see what I'm doing. For something that's come from China, yes, it's all, and it literally is all in Chinese if you look at this thing. I suppose I could get my girlfriend to translate it for me, but to be honest, I don't think I need. We've got a schematic diagram. We've got a component placement here. We've got showing us basically what what's what, R4 or R5. We can, using this and that, we can figure this out. We don't need to know what the Chinese is here. I mean, we can read resistor colour codes. We can read values on capacitors. And that's, apart from the IC, everything else is just passive components anyway, providing we get the caps in the right way around and we get the resistors in the right place. So there's nothing really else to go wrong. So we might as well crack on with it. Nice little circuit board. Even the circuit board, if we look here, that's all screen printed up. This isn't actually looking too bad. How shall we start with this? I think we'll start by putting the resistors in. Now, what have we got in the way of resistors here? One thing it is showing on the diagram here is these are what's that, so brown, orange, black. We've got 1, 2, 3, 4 of them, and these are miniature resistors, but we've actually been sent just 4 just normal resistors like that. So we'll have to they're 100k. We will have to fit them the best we can. But anyway, let's stick the first one of them in the board. What I'm going to do is I'm going to put everything that's flat on the board in first, and then we will we'll basically build the layers up. It makes it a little bit easier to solder. Let's put this first 100k resistor in. Now, I wanted some of the little TDA2030s. A lot of the cheap Chinese valve amps, not valve amps, guitar amps, sorry, that I've been playing about with, seem to use them for their output stage. So they're good for about perhaps 10 or 15 watts. I mean, 15 watts is probably pushing it for them, but it's certainly good enough for 10 watts. So I've got one I'm repairing at the moment. It's got a blown one in, but I thought I'd build this kit up. I'm not just going to salvage that. I have ordered some more. Oops. Put it first. There we go. It's definitely not the best iron for doing very intricate work. That not horrendous, but that's okay. That's our first resistor in. Then we want a 4.7K there, and we want a 10 ohm. Now let's have a look what we've got here. That is our 10 ohm. Yep. Brown, black, black. And that one goes in there. That's our 6. Which means that this one is our 4.7 because that's the last of them. Last which are going in this way around. We'll stick that in there like that. And let's get these soldered in position. And these legs out. There we go. Just put a bit of weight on the board. Sometimes it helps just try and keep the board as flat as you can. So otherwise you do risk having one side of the component like bobbing up a little bit, and it doesn't look great. I mean, it'll still work just fine, but it doesn't look brilliant. Let's go in here and solder this one here. Oops. There we go, that's one. Look at this one. Oops. Okay, that's okay. Certainly isn't the best for doing PCB work, this iron. I haven't ordered any more tips for it. I don't know whether I'm going to bother or I'm just going to save up a little bit and get a better iron for doing PCB work. Yeah, they're solid enough, they're not dry or anything, it's just they're a bit ugly with that iron because it's not got really a usable fine tip on it. It's too much of a point, so they could go about filing the tip on it, but anyway, they're in. Right, so next let's fit that diode, a little diode to go in here. Unfortunately, again on the silk screen it is marked. Let me see if I can zoom you in a bit more. Oops, that's the wrong way. It is marked actually on the board there which way round the diode goes, so we'll get the diode. I think this is the last component to go absolutely flat on the board. Let's stick that in there. Down you go. And we'll solder that in place. Put that to hold it. Okay, that's in. That's all right, and that's in the right way around. Now let's fit these two capacitors next, because I think they're going to be the next highest thing on the board. Now they're both 0.1 UF, so we don't have to worry there, and they're non-polarized, these capacitors. Unlike the rest of the capacitors going in the circuit, like I said, these can just go in either way. So we'll stick them in. Going to slightly bend the legs out of them just to help hold them in position while we solder them in position. No, I'm not liking this iron at the moment. It's struggling doing some of this through hole stuff. You have to hold it in a really critical way to actually get enough contact between your lead and your pad to actually get a decent solder. And it does tend to leave it rather high on the board as well, which I don't like. I mean, it'll do. I mean, it's not as though they're going to come off. It's not as though we've got a dry joint or anything. It's just they aren't very neat. But anyway, like I said, it's more just to see what this board's going to be like. I think we'll put the 100k resistors in next. The rest of them. Like I say, on the cheat chart, we've got, it showed miniature. You can see like these. It shows little miniature resistors for them 3100k ones. What I'm going to do, I'm going to use the regular resistors and just bend them up like that, because that's what they sent me, and that works just as well. The one in there, we'll put all three in, and then we can solder them in place. Another one in there like that. One more. Now, you never want to put too many components in a board at once, otherwise you do start to struggle, because you can't then get in with your soldering iron to actually solder them in place. So it's about as many as I'd normally do. Right, let's get in there and solder them in place. One. Two. I might have to do is solder something and then trim the legs just to give me a bit more space to actually, you see what I'm doing there? To actually give me some more space to get in to solder them. Now ideally you'd want something to hold this board down as well. That seems okay. That's come up a little bit as I've soldered it in place, so I'm just going to reheat that leg, and there we go. Yeah, I'm happy with that now. And that straight, and we've got this last one to actually glue down. And I can get in from it from this angle. There we go. Last one is here. And that's that one done. And trim them legs off. And I will be keeping all these legs. I have my little leg pot here. And we collect all them up and we stick them in my leg pot. And then when I need a little bit of something to bridge a broken trace on a board, I have this pot ready. Or anywhere else where I just need a small piece of wire to bridge something, they're there already, all ready to go. Right, let's get these snipped off. There we go. Not the neatest of jobs, but this iron really isn't that suitable for doing this kind of solder work. Actually, I found it slightly easy to solder on that. Atari, they're not Atari, that Sega, that 40-pin IC socket the other day. And that wasn't quite too bad to do. Right, let's have a look here. So we've got C4 and C5, which are 22 UF. We've got a C3, which is 2.2 UF. We've got 1000 UF in the 100 UF in the 2200 UF. So let's start with the smallest values. So this is, that's a 22 UF. And that's a 22 UF, so we might as well stick these in first because they're the smallest ones. And we go that side like that. Unfortunately, like I said, it's marked which side's negative, so we're good there. We can solder these in position now. Just make sure they're nicely seated. Yeah, they're both nicely seated. Let's get them snipped off. There we go. Now we'll put that 2.2 in, which is that one there. There we go. I just left a big blob on that leg there, but never mind. It'll be alright. Components in position, it's the right way around. That's all we really care about. Let's put this 100 in. I should have really put the outputs in before I went this far, but never mind. 100 goes in there. Oops, there we go. Oops. I'll sit up. There we go. Once we've got the first leg in, it's not so bad. And that's soldered. Let's get in. I'll have a horrible nasty tail there, I'll tidy that up after. I'll just tidy that little tail up. There we go. No, not a good iron. I will say this now, not a good iron for PCB work this. So great for doing point to point on old boards and stuff, but if you need to do stuff like this, it's not brilliant. Left a bit of a, get rid of that like that. Get rid of them. Okay, and we've got one cap left to go, which is that big. In fact, let's put in the bits I didn't put in before, which are our little connections. In fact, I don't think I'm going to use one of them for power. Let's see if I've got any red and black wire. I would much rather run some red and black wire off there for power. Let's see what we've got. You just have to bear with me a second, folks, while I just find something suitable. Ah, you look suitable. Just connect some wires on for the power. In fact, I might as well do all these with wires on rather than use them connectors. Again, it's left a few little tails, but at least we've got a decent enough solder joint there. Let's snip them off. Tidy that up there. There we go. So they're on decent. Let's put the. In fact, let's put the IC in. That's probably a good idea at this point. That way, is it? No, 3 at the front, 2 at the back. Just got a little bit bent in transit. There we go, that's in. I have to hold that steady while we solder that in position. I think I'll be going on eBay tonight and seeing if I can get a new element for my old Maplin's iron, because I do miss it. Yeah, this isn't a patch on it. It's got some nice features, but in fact what I'd like to do is to use the handpiece off the Maplin's on that controller, because that is a nicer controller. But it does have one annoying feature, which is it goes into standby after so long of just being switched on. So you have to make sure before you do your soldering that you've actually got it in the right. It's not gone into standby. Right, okay. Let's put this last capacitor in. There we go. That's where you're going to live. No, it actually is horrible for doing PCB work. I don't think I'll be doing any more PCB work till I can replace that. Right. It looks ugly. Hang on, I've got the last few bits to connect onto. Now, how we're going to do that? I'm going to use pity I've no little. Yes, I could do that actually. That would work really well. I've had a little brainwave. Well, I think it's a brainwave anyway. We'll scratch about back here. I'm sure to find. No. Not found what I was hoping to find. Have a look in here. I've got a piece here. I'm going to fit a couple of them for the inputs. I just want a couple of bits of wire to go for the output. It doesn't matter too much what it is. That'd do nicely. It doesn't matter too much. Right, that's our output wires. And for the input, I'm just going to connect in one of them. It's going to be a pain in the ass to solder in place, but never mind, we'll manage it. Especially with this crappy iron. Right, let's see if we can do this. I wish I could do that thing that Big Clive does where he holds it, solders it all with like one hand. I've never seen anyone be able to do that before. That's just branded that into my finger, but at least I've got it held in position. I've got it where it should be. Let's just make the other connection. There we go. Again, that's ugly as sin, that connection. Really, I'm not liking that iron for PCB work. Not going near any of my vintage computers. It's been near my Master System, I suppose. I think I may wait until I get something else before the next Master System instalment, because I don't want to bugger it up with that iron. I managed to do the other one okay with it, but I think that might have been a fluke. That certainly wasn't easy to do. Let's get these wires stripped and connected. Alright, there we go. In there. Might be a tiny bit thick, this. Oh, there. They've gone in. Where's my solder gone? It's almost like lead-free solder, this, the way it's behaving on this, with this iron and this board. I mean, I know it's not, it is good old-fashioned leaded solder. I wouldn't have any of that horrible lead-free stuff anywhere near my workshop, but certainly not. And the iron's hot enough. Okay, they're on. Okay, let's get a little bit off the end there. Right. So that's our outputs, that's our voltage, and then we've got a funky little input there that we can rig up to some audio. In fact, I've left my audio device downstairs as well. Oh bugger. Oh, we need a heatsink. I've got a scrap amplifier here. I think that'll where is it now? Yeah, that'll donate its heatsink. Let's get that off there. Oh, it's going to be absolutely full of heatsink compound, lovely. Should have prepared this before I started making the video, really, shouldn't I? There we go. There we are, that's off. Yeah. I'll find a cloth or something I can clean some of that thermal grease off on. There we go. It's already got a thermal pad on it as well, an insulating pad, because they're not meant to short these things out. So also in the kit comes, if you look here, with a little spacer for the screw. There's already a pad on the back of this heatsink, so I can't see why I have to disturb it. I mean, I've got a nice brand new one there for another IC. I'll reuse this one since it's in good condition. Get the screw to line up with the hole in there. Hopefully it's the right thread. Should be. Ugh. Yeah, there we go. Let's get that sat where I want it. And there we are. So by the in fact, it didn't come with a heatsink, unless we do need to run it with a heatsink. £1.11p for that. So let's see whether it works. That's all being given that I've actually built it correctly. I think I have. I think I put it together right. Let's we'll get a test speaker. I better zoom you out a little bit, Hunter. We've got my my trusty test speaker here. I've got this rigged up with some crock leads. So let's connect the speaker up to the output. There we go. Let's use this. Let's use this test lead, and we'll connect up with that little pin connector there. So that's audio in, and we'll hook it up to my bench supply. Now my bench supply can only provide ½ an amp, but it should be enough to get a test out of this thing anyway. It can give us the 12 volts that we need, so let's switch on. Let's take that up to about 12 volts. And it's picking a bit of interference up, but it definitely works. Let me just, I'll just pause here and I'll just go and get an audio source, and we'll see what it sounds like with an audio source up it. Back in a sec. Okay, I'm back, and as you can see, I've got my trusty old tablet connected up. I've got a track queued up on that. Now I can't play too much because in fact, sod it. You know what? I'm not making any money from these videos. I don't honestly care if I get a copyright strike on it. So I'll just play some music and see. You can see what this thing sounds like. I'll turn the volume down on here before we start, because obviously we've no volume control on this or anything. And we will only get one side coming through, because obviously this is a mono amplifier. I'm just going to connect it, just one channel up, just so we can get some proper audio through it. So let's connect that up like that. We'll switch on. And that should be working now. So if I press play on here, hopefully we should start getting the music come through this little amplifier and through the speaker, and we'll see what it can actually sound like. So well, it is working, so turn the volume up.
Give it away, give it away. I should give it away, give it away. And I don't want to lose my mind. No, I don't want to lose my mind.
Actually not too bad.
Wicked day, such a wicked day, wicked day.
That's playing through that old hi-fi speaker there.
Don't want to waste my time.
There's a bit of something in the background, but
what the hell
try to lower on the voltage.
What the hell are you doing when you're away?
Heatsink. It's not even warm yet, that's stone cold. I'm sure none of the quality of these components isn't exactly going to be top rate or top notch, or like £1.11p. That included postage all the way from China, so it's actually not bad. Let's play something else through it. What have we got here? That doesn't sound bad. That doesn't sound bad at all. It's the track I use quite often for testing amplifiers, and that sounds pretty good, to be honest. Stop that now. So yeah, I mean, that's really what I wanted to just do, is just build this little thing up and let it have a little play and see what it sounded like. And I'm actually pleasantly surprised with it. For, like I said, for £1.11p, You really can't complain. The only thing I need to supply was the heatsink for the back, and they even supplied the screw, the spacer, and even a little insulating pad like that for behind it. So yeah, really quite impressed with that for the money. I can't actually remember which seller I got it from, but I'm sure if you go on eBay and you just type in TDA2030A kit or PCB, they'll come up. There's other people selling them. You can buy them in the UK. I think someone's importing them, but they're like £3.50, something like that, and I think there's even postage on top of that. If you don't mind waiting the 10 days, 2 weeks or so, £1.11 from China, including the delivery, you really can't go wrong. It's apparently telling us that our input voltage can be 9 to 35 volts. So well, I've got 12 volts going into it there. We may have a play about at some point. See, in fact, yeah, no, I'm not going to do it in this video because this is already getting quite long with the build up and everything. But I will play more with this, and like I said, probably see how well I can get it to drive a modern pickup cartridge. I will need some little preamplifier for it to do that, but it could be the basis of a good replacement unit for one of the perhaps not quite as valuable record players we get out there, because I still like to save them. It's just you can't put a 30 quid cartridge and, you know, 10-15 quid's worth of valves, 20 quid's worth of valves in them when they're only worth 40 quid when they're done. So something like this may be another solution. But yeah, as I was saying, like I said, I don't know exactly where, I can't remember which the exact seller was, but if you do that, if you search on eBay for TDA2030A PCB or a kit or something like that, I'm sure you will find something, and pick one up and have a play with it. Anyway, I'm going to leave it there for now. I hope you found that was useful. Anyway, so thanks for watching, and goodbye.